we're going to talk about is 6-2, the slope of change, you're going to be able to find slope. A constant decrease situation. We know a constant decrease situation has a slope of a line that goes downwards from left to right, as you can see in this graph. It says during a fire drill in a skyscraper with 50 floors, people were asked to move swiftly down the stairwell to see how much time it would take to empty the building in a real emergency. The evacuation of the people on the top floor was monitored closely. They walked down the stairs at a rate of 5 floors every 2 minutes, or down 2.5 floors each minute. This is a constant decrease situation. The floor number decreases at a rate of 2.5 floors per minute. You can see the constant decrease by graphing the floor of the people after 0, 1, 2, 3, 4 minutes of walking. Below is a table of ordered pairs, time to floor, charting their progress. So at 0 time, they were on the 50th floor. After the first minute, you take off 2.5 floors, and they're at 47.5. After 2 minutes, take off another 2.5, you get 45, so on and so forth. And that's how they got the graph. All they did was plot these points, 0, 50, 1, 47.5, so on and so forth. Connected the dots, and what they got was a decrease negative slope function. The constant slope of a line. Notice that all the points on the graph on page 333 lie on the same line. In any situation in which there is a constant rate of change between points, the points lie on the same line. This constant rate of change is called slope. A has its own slope, B has its own slope, C has its own slope, and D has its own slope. Slope of a line is similar to rate of change. You have 2 points, x1, y1, you have x2, y2. Slope is y2 minus y1 divided by x2 minus x1. In contrast, consider the graph at the right. On this graph, no 3 points lie on the same line, and the rate of change between each pair of points is different. This was also the case of the graph of the population of Chicago that we did in lesson 6-1 on page 325. If you look at slope A, okay, its slope is -3 over 1. It went down 3 units, went to the right 1. Slope B is down 1 to the right 1. Down 1 to the right 1. For C, it went up 2 to the right 1. Up 2 to the right 1. Slope D, it didn't go anywhere. It stayed the same, but went to the right 1. So 0 over 1 is 0. We can also call slope rise over run. Let's look at example 1. Find the slope of the line L below. Okay? As Mr. Johnson just said, we can also think of slope as rise over run. Okay? What we need is 2 points to use our equation y2 minus y1 all over x2 minus x of 1. Okay? So let's go back to our problem and let's find those 2 points. Well, we have 2 points. I'm going to call this my first point because it's the first point coming in from the left. So we have 2 points, a negative 3, comma 7. And we have the other point, 15, comma 10. Looking at my paper, I have my 2 points. I'm going to call this x1, y1, because that's the first point that I came to. I'm going to call this x2, y2. Now you need to note, it doesn't matter which one you call x1, y1, or x2, y2, as long as if this is x1, then this is y1. Don't call this x1 and call this y2. If this is x1, this is y1. If this is x2, this is y2. Okay? So now we're going to put it in the formula. Well, what's y2? Well, y2 is 10 minus y1. What's y1? 7. Divided by, what's x2? 15. Minus, what's x1? A negative 3. We do our math. 10 minus 7 is 3. 15 minus a minus is plus. So 15 plus 3 is 18. To reduce that down, 3 goes into both of these evenly. 3 divided by 3 is 1. 18 divided by 3 is 6. So the slope of that line containing those 2 points has a slope of 1 over 6. That means it has a rise of 1, has a run of 6. Looking at example 2. In the coordinate grid below, each square of the grid is 1 unit. Find the slope of the line. As I said, you can look at this as rise over run. So if we want to look at the line from A to C, A to C, we want to see what the slope of that line is. Well, I'm going to pick another point. I'm going to look at B to C because that point is also on the line. So to find the slope of line AC, I'm going to use this point and this point. Remember, it doesn't matter which points to use, just as long as they're on the line. This says my run is 2, my rise is 3. Now notice it's 3 in the negative direction. So my slope has to be a negative value. So my run is 2, my slope is 3. So for AC, my slope is down 3 units, to the right 2 units. Down 3 units, to the right 2 units. My rise was a negative 3. My run was 2. It went to the right 2 units. It went down 3 units. Down meaning negative. Let's look at DF. If we look at line DF, E is also on this line. So if you look at E, from E to F, I have a run of 3, but a rise of 1. I have a run of 3, and I have a rise of 1. Run of 3, rise of 1. So line segment DF slope it has a rise of 1, it has a run of 3. So its slope is 1 over 3. Lines with negative slopes, such as line segment AC in example 2, go downward as they move to the right. We looked at that yesterday. Lines with positive slopes, such as line segment DF in example 2, go upward as they move to the right. If a line is horizontal, it is neither increasing or decreasing. And likewise, the slope is 0. Anytime you see a horizontal line, just like yesterday, you know the slope is 0. If the rate of change or slope is the same for a set of points, then all the points lie on the same line. If the rate of change is different for different parts of a graph, then the graph is not a line. So what you can do is you can check different points that are on the same line, and if they all have the same slope, then they all lie on the same line. We call that collinear. So we could check the point D and E, and they would have the same slope as E and F. Okay? They have the same slope because they lie on the same line. Example 3 says show that negative 2 comma 5 and 2 comma 3 and negative 10 comma 9 lie on the same line. B says give the slope of that line. Well, in order to do this, we have to do two things. Okay? I need to find the slope of points negative 2 comma 5 and 2 comma 3. I need to find the slope of a negative 2 comma 5 and a negative 10 comma 9. So I did the first two, and then I did the first and the third. So now I also need to find the slope of the second and the third. Don't forget your symbols. So looking at this, what I need to do is I need to make sure that all these slopes are the same. If they are the same, then all these points lie on the same line. Seems like a lot of work. It's not that much. I call this x1, y1 because that's the first thing I come to. I call this x2, y2 because that's the second thing that I come to. Use my slope formula. y2 minus y1 all over x2 minus x1. What's y2? y2 is 3 minus y1 is 5 divided by x2 is 2 minus x1 is a negative 2. 3 minus 5 is a negative 2. 2 minus a minus 2, that's plus, is 4. We all know a negative 2/4 reduces down to a negative 1/2. So the slope of those 2 points is a negative 1/2. Let's check out the slope of these 2 points. y2 is 9, minus y1 is 5. x2 is a negative 10, minus a negative 2. 9 minus 5 is 4. A negative 10 minus a minus 2 becomes plus. So negative 10 plus 2 gives me a negative 8. Positive divided by a negative equals a negative number. 4 divided by 8 is 1 over 2. Are those slopes the same? Yes. If they weren't the same, I wouldn't have to go any further. But since they are the same, I need to check this one. So, x1, y1, x2, y2. y2 is 9. Minus 2. Sorry, minus 3. x2 is a negative 10 minus 2 equals 9 minus 3 is 6. Negative 10 minus 2 is a negative 12. Signs are the same, so you add them together. Positive divided by a negative is negative. And we all know 6/12 is 1/2. Since all of the slopes are the same, all these points lie on same line. Okay? All these points lie on the same line. So going back to the questions, show that they lie on the same line. We did that. All the slopes are the same. What is the slope? The slope was a negative 1/2. Finding the slope of a line from an equation for the line. You can find the slope of any given line given its equation. Use the equation to find 2 points on the line and calculate the rate of change between them. Example 4 says find the slope of the line with the equation 2x minus 5y is equal to 4. How we're going to do this is we need to find the x and y intercepts, and that will give us 2 points. If you remember, your x-intercept is when y equals 0. Your y-intercept is when x equals 0. Okay? So looking what I wrote down here, the x-intercept is when y equals 0. The y-intercept is when x equals 0. Here's a y-intercept. X equals 0. It's on the y-axis. An x-intercept is a point on the x-axis where y is equal to 0. Okay? So to find those 2 points, if we want to find the x-intercept, I let y equal 0. So for this equation that they gave us, 2x minus 5, I want y to be 0, because that's the only time I'm going to have an x-intercept, is equal to 4. Well, 5 times 0 is just 0, so it leaves me with 2x is equal to 4. I divide by 2. X equals 2. So we know a point, the x-intercept, is 2, 0. X value first, 0 second. Y value second. X, Y. To find my y-intercept, I let x equal 0. So 2 times 0 minus 5y is equal to 4. Well, that's gone. Leaves me with the negative 5y is equal to 4. I divide by a negative 5. Y equals a negative 4/5. So the point for that, my y-intercept, is 0, comma, negative 4/5. Now, like I said, we have 2 points now. Now that we have 2 points, 2 comma 0 and 0 comma negative 4/5, I can find my slope. 2 points will give me a slope. These are 2 points that were on my equation. So, x1, y1, x2, y2. What's y2? Negative 4/5. Minus y1 is 0. Divided by x2 is 0 minus 2. Leaves me with a negative 4/5 divided by a negative 2. Well, negative divided by a negative is positive. 4/5 divided by 2 looks like 4/5 times 1/2. Which you all are going to tell me is 4/10, which is equivalent to 2/5. Correct? So we know that equation slope is a positive 2/5. So what we should know is that line is going up from left to right. That is all I have today. We'll do questions tomorrow. Good luck.